Well, welcome to Study Guide Forum. Um, Here we have a question that we want to look at that has to do with equilibrium constants, how to calculate it. And at this time, before I continue, I want to encourage you, if you know you have not subscribed, and you make sure that you subscribed. I want you to share, comment, and then as we get along with this, you find out the easy way of calculating equilibrium constant of a system. All right. Here we have a question. The question said that given that the partial pressures of the following substances at 45 degrees Celsius are hydrogen. Hydrogen is 0.07 atmosphere. Iodine is 0.5 atmosphere. And hydrogen iodide is 0.3 atmosphere, and this is the chemical equation of their equilibrium system, their chemical equation. And then they said calculate the equilibrium constant for the reaction at 45 degrees Celsius. Now, second question said calculate the equilibrium constants for the backward reaction. That means what we're going to do here is we have two questions to look at. When we're going to solve for the equilibrium constant. After the equilibrium constant, then we'll look at the backward reaction. So let's quickly do justice to it. We know that for equilibrium constant is, for that we have it to be so if you have been with us all this while, you find out that in our subsequent classes, the previous classes, we were able to explain some of these things. So this is more like a continuation from where we have stopped already. This is what for this very chemical equation now, or for this chemical equation, we're looking at the equilibrium to get the equilibrium constant is by using this formula. So what we have here, since we have their pressure, the partial pressure for each of them, then for this potassium iodide will have 0.3 raised to the power 2, and then the next one we have there is for the hydrogen we have 0.07 times 0.5 for iodine. So when we sum up everything, if we do the calculation, summing up everything, we will have, oh my god, if we sum up all these things, the final answer will be this. So this is the equilibrium constant of the forward reaction. The next one we are going to find out here is the equilibrium constant of the backward reaction, when the reaction is going backward. So for that, equilibrium constant for the backward reaction is inverse of the equilibrium constant of the system. You can use X here to represent the system. So since the equilibrium constant of this one, this is the equilibrium constant of the system, the forward reaction. So then for this backward reaction means 1 over 2.6. That will give us 0.38. All right, thank you so much. I want you to make every effort to subscribe, like, comment, and then share. Thank you.